Rational function applications, question 5. A river flows 2 kilometers per hour and John takes 6 hours to row 16 kilometers up the river and 16 kilometers back. How fast did he row? Well, I've taken a couple of examples, in fact just two examples here to take care of these questions on rowing. Okay, so let me explain you what's happening here. Let's assume that this is the river, right? And now the current river is flowing downwards. Let's assume that, right? So let's say the river water is flowing this, right? So the question here is that John takes 6 hours to row 16 kilometers up. Let's say he goes from here to here, right? And that is 16 kilometers. And if you go against the current, then your rowing speed is lesser by the speed of the river, okay? And if you go in this direction, then you are moving faster, correct? So that is how you have to see this question. Now, either case, distance traveled, so it rose 2 kilometers per hour. River flow, so river speed is 2 kilometers per hour, correct? And John takes 6 hours to row 16 kilometers up and 16 kilometers back. So this distance from here to here is 16 up and this is 16 down. And total time is 6 hours for the whole trip, right? So let us say the speed of rowing speed of John is, so let John row at speed of J in still water. Okay, so when he's rowing against the water, then the net speed is J minus 2. And when he's rowing with the water, the speed is J plus 2. Well, time, as you know, so we will take care of this triangle also, which is our distance time triangle, correct? Okay, so the distance time triangle says that distance is speed into time. So distance is here, distance, speed and time, correct? Now we want to find time, so time is distance divided by speed, correct? So total time taken is time to go up and time to come down, correct? So time to go up and time to go down, right? And that is total. When we add them, then the total time is how much? 6 hours. Is 6 hours. Is that okay? So that is what is given to us, and we need to put it in the equation form. So time to go up is distance divided by speed. Distance is 16. So it is 16 divided by speed. When you go up, it will be minus the river speed, right? So we say J speed minus 2. And when you're coming down, then the river helps you to move faster. So the speed is J plus 2 and the total time is 6. So that's what you get. And that's your equation on this. Now, simplifying it. So I'd like you to use the technique which I taught you in previous 3 examples. Okay. So we'll multiply both sides by common denominator. And here the common denominator is J minus 2 times J plus 2. Also remember product and sum. It is J square minus 4. Okay. Anyway, so when we multiply by J minus 2 times J plus 2, we get 16 times J plus 2 here, right? And here we get 16 times J minus 2. In a way, it's cross multiply, which is 6 times J minus 2 times J plus 2, okay? So that's what you get. So when you open the bracket, you get 16J plus 16J makes it 32J, right? So we get 32J, and 16 times 2 is 32, minus 32, that becomes 0. So we're left with 32J here, and here we have 6 times J plus 2 times J minus 2 is J square minus 4. Is it okay? So that's what you get on the right side. Now we can simplify it. We can divide by 2. Okay, let's divide by 2. Simplifies a bit. So we'll open this. 3 times j square minus 4. Okay. Let's bring the terms to one side. Then we have a quadratic equation to solve. It is 3j square minus 16j minus 3 times 4, 12. So that's our equation, right? Now we can always use quadratic formula and solve it. So let's use the quadratic formula and solve it. So quadratic formula says that let me write here, j equals to minus of this, which is 16, plus or minus b square, which is 16 square, (256), and 4 times 3 times minus 12. So it becomes plus, right? Plus 4 times 3, 12, and 12 times 12 is 144. Square root divided by 2 times a, which is 6, correct? So we get 16 plus or minus. So let me do here plus 144. It gives me 400, and square root of 400 gives me 20. So I got 20 here divided by 6, right? Which gives me, so we cannot take negative because the speed has to be positive. So it is 20 plus 16 divided by 6. So we get 20 plus 16, which is 36, divided by 6 is 6, right? So we get 6 as our answer. So Joe's rowing speed in still water is 6 kilometers per hour. So that's what we get. So the answer here is, how fast did he row? So it is 6 kilometers. It's better, it is important to write units, okay? So Joe rowed at the rate of 6 kilometers per hour, and that is actually in still water. So it's better to put it, right? In still water. Of course, when you're going against it, it'll be 2 less in this case and 2 more while coming with it, right? So that's how you do this kind of question. Thank you.